Forum management has decided to merge the AFCI topic area with the NEC topic area. This decision was made due to an insufficient number of new AFCI-related issues to justify keeping it as a separate topic area. This consolidation allows for better organization and efficiency in addressing AFCI-related concerns. All previous AFCI-related issues have been or are being moved to the NEC topic area. If you have a question, comment, or issue to raise concerning AFCIs, you are encouraged to post it in the NEC topic area. Alternatively, posts may be placed in other topic areas if deemed more appropriate based on the content. However, to maintain clarity and prevent confusion, please ensure that each post is placed in only one topic area. Duplicate posts will be closed promptly upon detection. Members are advised to refer to the NEC topic area for historical AFCI-related content. In summary, the change involves firstly, the elimination of a dedicated AFCI topic area, secondly, the relocation of all existing AFCI content to the NEC topic area, and thirdly, the instruction for users to post future AFCI-related inquiries within the NEC topic area. The focus is on streamlining the forum and avoiding redundant posts. This procedural change intends to create a more efficient and focused platform for electrical discussions. The National Electrical Code, or NEC, is a widely adopted standard in the United States for the safe installation of electrical wiring and equipment. It is not itself a law, but it is commonly adopted into law by states and municipalities. The NEC covers various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. Article 100 of the NEC provides definitions for terms used throughout the code. Article 110 covers requirements for electrical installations, including workmanship, equipment approval, and wiring methods. Chapter 2 addresses wiring and protection, including branch circuits, feeders, and overcurrent protection. Chapter 3 covers wiring methods and materials, including raceways, cables, and conductors. Chapter 4 addresses equipment for general use, including switches, receptacles, and luminaires. Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 addresses special equipment, including electric science, elevators, and electric welders. Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and communications systems. Chapter 8 covers communications systems. Chapter 9 contains tables and examples for calculating conductor sizes, raceway fill, and other electrical parameters. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is essential for electricians, engineers, and other electrical professionals to stay up to date with the latest version of the NEC to ensure compliance and safety. Grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. Bonding connects all non-current carrying metal parts of an electrical system together, creating an equipotential plane. This minimizes the risk of electric shock by ensuring that there is no voltage difference between metal parts. The NEC specifies requirements for grounding and bonding in Article 250. These requirements cover grounding electrodes, grounding conductors, bonding jumpers, and equipment grounding. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This protects equipment and wiring from damage due to overload and short circuits. The NEC specifies requirements for overcurrent protection in Article 240. These requirements cover the selection and installation of overcurrent protective devices, including their ampacity, interrupting rating, and coordination. Proper overcurrent protection is essential for preventing electrical fires and equipment damage. Wiring methods are the ways in which electrical conductors are installed and supported. The NEC recognizes various wiring methods, including rigid metal conduit, electrical metallic tubing, non-metallic conduit cable trays, and various types of cables. Each wiring method has its own advantages and disadvantages depending on the application and environment. The NEC specifies requirements for each wiring method in Chapter 3. These requirements cover the types of conductors that can be used, the methods of support, and the protection against physical damage. Proper wiring methods are essential for ensuring the safety and reliability of electrical installations. Electrical boxes are used to enclose and protect electrical connections. They come in various shapes and sizes depending on the application. The NEC specifies requirements for electrical boxes in Article 314. These requirements cover the types of boxes that can be used, the methods of support, and the number of conductors that can be installed in a box. Proper electrical boxes are essential for preventing electrical hazards and protecting electrical connections. Electrical panels, also known as load centers, are used to distribute electrical power to various circuits in a building. They contain circuit breakers or fuses that protect each circuit from overcurrents. The NEC specifies requirements for electrical panels in Article 408. These requirements cover the types of panels that can be used, the methods of installation, and the labeling of circuits. Proper electrical panels are essential for ensuring the safe and reliable distribution of electrical power. Lighting is an important aspect of electrical design. The NEC specifies requirements for lighting in Article 410. These requirements cover the types of luminaires that can be used, the methods of installation, and the control of lighting. Proper lighting is essential for providing adequate illumination and ensuring safety. Electrical motors are used in a wide variety of applications, from appliances to industrial equipment. The NEC specifies requirements for electrical motors in Article 430. These requirements cover the types of motors that can be used, the methods of installation, and the protection of motors from overloads and short circuits. Proper electrical motors are essential for ensuring the safe and reliable operation of equipment. Appliances are electrical devices that perform specific functions such as cooking, cleaning, and heating. The NEC specifies requirements for appliances in Article 422. These requirements cover the types of appliances that can be used, the methods of installation, and the protection of appliances from electrical hazards. Proper appliances are essential for ensuring the safe and reliable operation of household and commercial equipment. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies requirements for electrical installations in hazardous locations in Articles 500 through 516. These requirements cover the types of equipment that can be used, the methods of installation, and the protection of equipment from ignition. Proper electrical installations in hazardous locations are essential for preventing fires and explosions. Healthcare facilities have unique electrical requirements due to the presence of sensitive medical equipment and the need to protect patients from electrical shock. The NEC specifies requirements for electrical installations in healthcare facilities in Article 517. These requirements cover the types of equipment that can be used, the methods of installation, and the grounding and bonding of electrical systems. Proper electrical installations in healthcare facilities are essential for ensuring patient safety. Swimming pools and spas have unique electrical requirements due to the presence of water and the risk of electric shock. The NEC specifies requirements for electrical installations in swimming pools and spas in Article 680. These requirements cover the types of equipment that can be used, the methods of installation, and the grounding and bonding of electrical systems. Proper electrical installations in swimming pools and spas are essential for ensuring the safety of swimmers and bathers. Renewable energy systems such as solar photovoltaic systems and wind power systems are becoming increasingly common. The NEC specifies requirements for renewable energy systems in Articles 690 and 691. These requirements cover the types of equipment that can be used, the methods of installation, and the protection of systems from electrical hazards. Proper renewable energy systems are essential for ensuring the safe and reliable generation of electricity from renewable sources. Conductors are the wires that carry electrical current. The NEC specifies requirements for conductors in Article 310. These requirements cover the ampacity of conductors, the types of insulation that can be used, and the methods of installation. Proper conductors are essential for ensuring the safe and reliable transmission of electrical power. Raceways are enclosed channels that are used to protect and support electrical conductors. The NEC specifies requirements for raceways in Article 300. These requirements cover the types of raceways that can be used, the methods of installation, and the fill capacity of raceways. Proper raceways are essential for protecting conductors from physical damage and environmental conditions. Electrical services are the connection between the utility power supply and the building's electrical system. The NEC specifies requirements for electrical services in Article 230. These requirements cover the types of service conductors that can be used, the methods of installation, and the overcurrent protection of the service. Proper electrical services are essential for ensuring the safe and reliable delivery of electrical power to a building. Transformers are used to step up or step down voltage levels in electrical systems. The NEC specifies requirements for transformers in Article 450. These requirements cover the types of transformers that can be used, the methods of installation, and the protection of transformers from overloads and short circuits. Proper transformers are essential for ensuring the safe and efficient operation of electrical systems. Control panels are used to control and monitor electrical equipment. The NEC specifies requirements for control panels in Article 409. These requirements cover the types of components that can be used, the methods of installation, and the wiring of control panels. Proper control panels are essential for ensuring the safe and reliable operation of electrical equipment. Low-voltage systems are electrical systems that operate at voltages of 50 volts or less. The NEC specifies requirements for low-voltage systems in Chapter 7. These requirements cover the types of equipment that can be used, the methods of installation, and the protection of systems from electrical hazards. Proper low-voltage systems are essential for ensuring the safe and reliable operation of low-voltage equipment. Communications systems are systems that transmit information such as telephone, data, and video. The NEC specifies requirements for communications systems in Chapter 8. These requirements cover the types of cables that can be used, the methods of installation, and the grounding and bonding of communications systems. Proper communication systems are essential for ensuring the reliable transmission of information. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The NEC provides tables in Article 310 that list the ampacities of various types of conductors based on their size, insulation type, and ambient temperature. It is important to select conductors with an ampacity that is sufficient for the load that they will be carrying. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. The NEC recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of electrical systems. The interrupting rating of an overcurrent protected device is the maximum amount of current that it can safely interrupt without failing. The NEC requires that overcurrent protective devices have an interrupting rating that is sufficient for the available fault current at their location. It is important to select overcurrent protective devices with an adequate interrupting rating to prevent equipment damage and ensure safety. Coordination of overcurrent protective devices is the process of selecting and setting overcurrent protective devices so that they will trip in a coordinated manner. This means that the overcurrent protective device closest to the fault should trip first, isolating the fault and minimizing the impact on the rest of the electrical system. The NEC provides guidance on coordination of overcurrent protective devices in Article 240. Arc fault circuit interrupters, or AFCIs, are devices that are designed to protect against fires caused by arcing faults. AFCIs detect arcing faults by monitoring the current waveform and tripping the circuit when an arcing fault is detected. The NEC requires AFCIs to be installed in certain locations in dwelling units, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against electric shock caused by ground faults. GFCIs detect ground faults by monitoring the current balance between the hot and neutral conductors and tripping the circuit when a ground fault is detected. The NEC requires GFCIs to be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. Surge protective devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. SPD diverts surge current to ground, preventing it from damaging sensitive equipment. The NEC recommends that SPD be installed in electrical systems to protect against voltage surges caused by lightning, utility switching, and other events. Energy efficiency is an important consideration in electrical design. The NEC includes requirements for energy efficiency in various articles, such as Article 220 for load calculations and Article 404 for lighting controls. By following these requirements, it is possible to design electrical systems that are both safe and energy efficient.